Problem 2, we are given that x is uniformly distributed with interval of -1 to 1. So we can write the density function of x. Fx is equals to 0.5 when x is from -1 to 1 and 0 otherwise. And so based on the density function of fx, we can write the based on the distribution density function of fx, we can write the distribution function of x, which is equals to the integral of density function from -infinity to x. And this is equals to 0 when x is smaller than -1 and equals to 0.5 times x plus 1 when x is between -1 to 1, and it equals to 1 when x is greater than 1. And we know that the density function of y equals to e the power of -y times uy. So here we can also write the distribution function of y by doing the integral of density function of y. So the distribution function of y equals to the integral of density function of y from -infinity to y plus a constant value, and it is equals to and based on the property of density function, we know that when y is going to infinity, the value of density function or the value of distribution function of y equals to 1. So here c equals to 1, so we get the density function, so we get the distribution function of y equals to 1 minus e the power of -y when y is greater than 0 and 0 1 is smaller than 0. And let me take this smaller. Yeah. And from the problem, we know that we need to find the gx to make the distribution function and density function of y looked at like this. And we know that the distribution function of y equals to the probability of y smaller than y and y equals to gx. So here we can write take the inverse, we can get x smaller than So when we get this formula, we know that the distribution function of y and distribution function of x with the variable as the inverse of gx are the same. So then based on based on this, we need to observe the formula of distribution function of fx and fy. And so here, when x is smaller than -1, fx equals to 0. When y is smaller than 0, fy equals to 0. So this part are already the same. So here we need to focus another part. So here we focus on this part. When x is from -1 to 1, here when y is greater than 0, this, since we know that 1 cannot always be equal to 1 minus e the power of minus y. So here, these two must be equal. So based on this observation, we know that 1 minus e the power of minus 1 equals to 0.5 times x plus 1. So here we got gx equals to y equals to minus ln 0.5 times 1 minus x. And so here we got the value of gx by making these two equal and doing the observation. And we need to pay attention that this is from x from ranging from -1 to 1. So here y so here we have not got the expression of x greater than 1 yet. And here we need to pay attention that when x is greater than 1, the density function of the distribution function of fx is equals to 1. So how can we make the distribution function of y equals to 1? The answer is we need to make 1 approach infinity. That is, so we got that gx equals to, here when -1 smaller than x smaller than 1, and when x is greater than 1, as I have said that the distribution function of x approach infinity, so the distribution function of y also need to approach infinity. So here we have y equals to gx equals to infinity. So here we got the answer. And that's for problem 2.